All right. Talk about rational functions today. Things that we're going to do with rational functions. A rational function is a function with two polynomials, involved. So you kind of look at it as two separate problems. Okay, you've got some function up top and some function in the bottom, and we're going to do some parts. Parts of the whole function happen either with the numerator or the denominator. So it's kind of like two separate things that we'll deal with here. But one of the things that we're going to find for a polynomial function or a rational polynomial function is domain. We've been doing domain every section of every, anything we've talked about, we talked about domain. To find the domain of something that's a fraction that has x's in the denominator, what do? Set what equal to 0? The bottom part. The denominator equal to 0. Okay, solve it. That's how you find the domain. Then you want to simplify the fraction. And that's where factoring comes involved. Not all of them will simplify. Some of them will, some won't. I mean, you've got to factor it and see what does simplify. We'll talk about that as we go along here. And then we want to find these things called asymptotes. Asymptotes are pieces of the graph that shape the graph and based on what's happening in there. There are 3 different kinds of asymptotes that we'll find on the problems. There will never be all 3 on any one problem. It doesn't happen ever. Okay, so the first thing is vertical asymptotes. Vertical asymptotes happen when your denominator is equal to 0. The difference in this and the domain is the fact that we've simplified the fraction in between. Okay, your domain is found first. Then you're simplifying. Then you go to find your asymptotes. Vertical asymptotes may not always match the same numbers as your domain did. There may be some of them that go away for the vertical asymptotes because the fraction simplified. And we'll look at that. So denominator equal to 0. The same way you found domain, but you're looking at perhaps a smaller denominator than what you had to begin with because of the factoring and the simplifying of the fraction. Okay, vertical asymptotes, and then there's horizontal asymptotes. Horizontal asymptotes. There's a couple little rules for this. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0. Example of that. Maybe you got x squared plus 9x minus 3 over x to the third plus 1. Here's an example of one that has a horizontal asymptote at y equals 0. The degree of the numerator is what? 2. What's the degree of the denominator? 3. The top is smaller than the bottom. That automatically makes the horizontal asymptote y equals 0 every time. That's what's happening. Okay. important thing to know, remember. Okay. Horizontal asymptote also occurs if the degrees are equal. All right, so read this to you. If the degrees are equal, for example, g of x equals 3x squared plus 5x minus 7 over 4x squared minus 2x plus 13. If the degrees are equal, then the horizontal asymptote is at the ratio of the leading coefficients, is basically what I'm saying here. The coefficients of the degree terms. The degree of the top is 2, the degree of the bottom is 2. So that means there's a horizontal asymptote at the ratio of these coefficients, 3 over 4. So for this one, it would be at y equals 3/4. This one up here, it was a y equals 0. So we get a horizontal asymptote if the degree of the top is smaller than the bottom, and a horizontal asymptote if the degrees are the same. It's the ratio of the leading coefficients. Okay. That's when that horizontal asymptote occurs. Vertical asymptotes can occur in every problem. Not every problem will have a horizontal asymptote. Okay. Not every problem has a horizontal asymptote. Okay. Next type of asymptote is what's called an oblique. And you may hear me slip up and call it a slant asymptote, S-L-A-N-T. Slant asymptotes, oblique asymptotes, that means the same thing. We called them slant asymptotes when I was growing up in pre-cal and algebra. When I was in high school, they've since kind of thrown that out and started calling them oblique. It's a little bit more descriptive. It's slanted is the reason it was called a slanted asymptote. Okay, that only happens if the degree of the numerator is one more than the degree of the denominator. Then long division is used to find y equals mx plus b. Okay. So obliques happen only if you have something where you had maybe x cubed over x squared. Maybe it's x cubed plus 27 over x squared plus 9, something like that. That one would have an oblique asymptote because the degree of the top's 3, bottom's 2. We know that has an oblique. We would do long division to find it. Okay, this is where the long division is coming back in. Where I told you back in the section 2 where we were doing some long division, and I said you're going to need it. So this is where you need it, or one of the places you need it. Okay. All right. So what we're going to do here is we're going to do some just a few problems here where we're doing all of those things. We're going to find the domain. We're going to find vertical asymptotes. We're going to find horizontal or obliques. Maybe an important thing to write here, star with a note here, horizontal and obliques never occur together. They're not. You're never going to have a horizontal asymptote and an oblique because the rules for the degrees on the top and bottom, they're not the same, so you can't have them together. So there should never be that. Okay. So, and it is possible to not have a horizontal or not have an oblique. If it doesn't fit any of the rules, then you wouldn't have either of those. Okay. It's possible to have neither horizontal nor obliques with this stuff. So let's look at a few examples, and I think you'll start seeing it'll start clicking and making some sense to you as to what's going on. So let's start with this one. Example A. Here's our function, rational function in whatever form we want to do here. I'm trying to pick a good one to start with here. One that's not incredibly difficult, but not boring either. All right. X squared plus 7x plus 12 over 4x squared minus 1. So rational function, it's just fractions, ideal, kind of thing here. So things we want to do here are find the domain and then vertical asymptotes. If there are, there should be some of those. Horizontal or oblique. You can find out which ones they have from the beginning. Look at our degrees. Squared and squared, right? 2 and 2. So we're going to have a horizontal one where? At 1 over 4. The degrees are the same, so it's the ratio of the leading coefficient. So it's 1 over 4. So we have a horizontal at y equals 1/4. And if we have a horizontal, we don't have an oblique, so we just would say none. I usually just write none there on that. Okay. Now, one of the things that's really a helpful thing to do is to just factor everything in the problem if possible. Not every polynomial factors. These happen to factor. Factor the numerator, x squared plus 7x plus 12. X plus 3, x plus 4. The denominator factors as 2x plus 1, 2x minus 1. Just some basic Algebra 1 factoring. You're not going to get anything incredibly difficult to factor with this stuff. They're already complicated enough as fractions, so they're not going to give you just huge polynomials on top and bottom that you have to factor. The reason you want to factor it is you want to see if it will simplify. Are there any factors that would cancel out? No, none of the factors would cancel out. In order to cancel out, they have to match exactly the same on top and bottom. They don't match on this one. The factored form, though, helps us to find the domain. What do we do with to find the domain? Set what equal to 0? The denominator. So if I set 2x plus 1, 2x minus 1 equal to 0, since I've already got it factored, that makes that easy. Negative 1/2, positive 1/2. So the domain, all x's, so that x, as long as the x doesn't equal plus or minus 1/2. There's the set notation. We'll write it in interval notation. Stuff we've done before here, guys. This is not anything new. If you don't remember it, go back, look at your notes from previous chapters. That's stuff we've done before. All right. Now, since nothing's simplified, our vertical asymptotes will match these equations from solving the denominator equal to 0. Our vertical asymptotes will be at x equals -1/2 and x equals +1/2. Okay. Now, let's look at the graph of this whole problem to show what this stuff even means. What's it even mean to be an asymptote? What's it mean for a rational function? So let's graph that. So I'm going to hit y equals and parentheses. And since nothing's simplified, I'm just going to type in the original problem. A little quicker, type in x squared plus 7x plus 12. Close the parentheses, divided by 4x squared minus 1. We'll hit graph. I'm going to show you where these things are. Okay? Now, right here is where -1/2 is. There's this imaginary vertical line that's happening there. That's a vertical asymptote. Notice how this blue part kind of veers up and gets almost vertical as it gets closer and closer to -1/2. It gets closer and closer to it. It never really gets there, but it gets close. Okay? Over here, this is +1/2. Same thing's happening on this side if you think about where it's going. Now, where was our horizontal asymptote? 1/4. At 1/4, which is really close to the x-axis, see how these are flattening out here? That's that horizontal asymptote. That's the asymptotes shape the graph. They kind of guide the blue parts here in which way to go. That's what the asymptotes do. It doesn't draw them when you graph it on a graphic calculator, but they're there, and that's what they're the bounds for this thing. They're like the walls of this room. You can't go outside of them unless you do something different. Okay, and that's what's happening with these asymptotes. That's where they're at. That's what they're doing to the graph. Okay. All right, let's look at another one. See what's shaking with it. Let's say we have g of x is equal to, let's do x squared plus 7x plus 10 over x to the third minus 25x. Okay, so again, we're going to find the domain, the vertical asymptote, horizontal, and I'm abbreviating here, and that's what I expect you to do too. And Katie, I heard what'd you say? It's a what kind? Why? Okay, the numerator is less than the denominator, so the degree of top is 2, degree of bottom is 3. So it's y equals 0 as the horizontal. What's that mean about the oblique? There isn't one. None. Okay. Domain, how do we find that? All right. If I've got a denominator, it's got an x cubed minus 25x. I bet it factors. But x squared minus 25 will factor itself too, to x plus 5 and x minus 5. So GCF, you following the rules of factoring, GCF happens first, and then you look to see how many terms you got. You got 2 terms with a minus sign in the middle, x squared minus 25, that's a difference of squares. So that's how I factor the denominator. What's the numerator factor as? All right, so that helps us when we go to do our vertical asymptotes. Domain should be done before you simplify. Don't make that mistake. So the domain, we're going to set this entire factored form equal to 0. So we should get 3 restrictions on our domain because there's 3 factors with an x in it, right? So x equals 0, x can't equal -5, and x can't equal +5. So domain x such that x does not equal 0 or plus or minus 5. Interval notation for that, pretty ugly. Negative infinity up to -5, union. Yes, be able to recognize both of those. Be able to do both at some point. Okay, be able to do both. The interval is just a little long, but not too bad. So there's the domain in set notation. There it is in interval notation. The difference here is the vertical asymptotes because we get something to cancel out. Look at the factors that match. What factor matches? X plus 5 is going to go away. So the only vertical asymptotes I have are the ones that go with x and x minus 5. So the vertical asymptotes will be at x equals 0 and x equals +5. What's left on the bottom? That's absolutely right. After you simplify. The first example didn't simplify at all, so we still had everything the same. This one, we lose one part of the bottom because it cancels out. And the rule still stays the same as far as horizontal asymptotes go, because even if that's canceled out, the degree of the top is 1, the degree of the bottom is still 2, so it's still top is smaller than the bottom. So that doesn't change the rules. So doing the horizontal or oblique at the beginning is absolutely fine. It's not going to change anything when you simplify it.
So you got positive 5 because you said x minus 5 equal to 0.
Solved it for x. That's exactly right.
I just don't know how you're solving the g of x that thing equal to it in the blue.
I'm factoring. X method. 10 and 7. 5 and 2. That's how you get those factors. GCF. X squared minus 25. That's how you get those 3. X squared minus 25 is x plus 5 and x minus 5. So it's just factoring. I'm just trying to factor that polynomial as far as I can. And if it's a trinomial, you're going to try that x method. If it's a difference of squares, use that. If it's a larger polynomial or 4 terms, maybe you group it. Those rules that we use for factoring off, for a while could be helpful. Let's look at this one. I like this one. It's a good problem. 8x squared, well, we'll call this f of x, it doesn't matter, plus 26x minus 7 over 4x minus 1. This one's a little bit different, but it's still doable. So again, we're going to do domain, range, or well, not range, but horizontal asymptote, oblique asymptote. Why is this one oblique? Yeah, the degree of the top is 1 more than the degree of the bottom. Okay. So if we want to go ahead and do that oblique, let's do that long division that goes with it. So we're dividing 4x minus 1 into 8x squared plus 26x minus 7. So this is the process to get the oblique asymptote, is this long division. So remember, with the long division, we want to look at the front and say, what times 4x gets me 8x squared? 2x. And then I distribute and subtract. So 2x times 4x is 8x squared. 2x times -1 is -2x. Subtract. So that's going to be these canceling out. Positive 26 minus a -2x be 28x. Negative, negative makes positive. What times 4x gets me 28x? Plus 7. And that's 28x. 7. Turns out the remainder is 0 on that, but that doesn't really matter. This part is what we need. Our oblique asymptote is that line. Oblique asymptotes will be in slope-intercept form every time. Once you get mx plus b right here with the oblique asymptote when you're doing it, you don't even have to do this math here.
So you stop.
You just stop because you're not worried about the remainder.
But even if there's no stop, or would there be?
It doesn't matter what the remainder is. The remainder doesn't matter. As far as if there's just one piece up here, like it's just, there should be something with an X up here if it's oblique, if you do your degrees right, because the degree at top is one more than the bottom. There should have to be at least an X up here. And your slant asymptote or oblique asymptote could be just y equals x. That's a slope-intercept line. It just has a slope of 1 and the y-intercept of 0. So those could happen, but it's coming through. Once you get a y equals mx plus b, and you're going to have a remainder after that, you don't worry about the remainder when you're doing oblique asymptotes. It doesn't matter. So don't even worry about doing the work for that. Okay? So we got the oblique asymptote. It's y equals 2x plus 7. That means there's not any horizontal ones. Remember, they never happen together. Okay? So if you get one of those, you get the other one. All right? Now, domain. Do I have to factor the bottom? No, it doesn't need factoring, right? It's 4x minus 1. So
McKinley Weatherly report to the office. Also, seniors, don't forget the ski block. You have a meeting for project graduation in the cafeteria. Dual enrollment will meet for history during ski block. National FFA week. Those FFA members dressed up today needs to go by and see Mr. Lipford to get your name and draw. Thank you.
all right, so this one factors here as 4x minus 1 and 2x plus 7. So X method for factoring, it's a trinomial. And then it just so happens that this cancels out. There's nothing left on the bottom, so there can't be any vertical asymptotes. That's what's happening there. Okay? And then your left, just so happens what's left is the same thing as this. That don't want to always happen. It just happens to be that on this one. Okay? All right. You're going to need some practice with this. Tomorrow, follow those rules. You'll be fine. We'll do questions Friday and stuff before we do the quiz. May do the quiz toward the end of class Friday. That way you get some time to ask questions and really get it nailed down before we take the quiz. And then we'll go from there, okay? Appreciate it, guys. You guys have a good